We have, for speakers, Andrew Dugan, Senior Vice President of Technical Planning and Network Architecture from CenturyLink, Kevin Sheehan, who's CTO of the Americas at Ciena, and Daniele Mancuso, who is just recently, in fact, we had to update the slide, Executive Vice President of ICT Engineering. So I'm going to have each of them give you a quick bio about your role, and Daniele, we'll start with your new role.
Yeah, so good morning, everybody. As Rosemary said, I was recently appointed as Executive Vice President for ICT Engineering in Sparkle. Sparkle is the international company of Telecom Italia Group, which was a spin-off in 2003 with the mission of developing a wholesale business, mainly Europe, but then we expanded all over the world, and we have also established an enterprise business unit. In my role, I'm responsible for the technological innovation, the development and the planning and the deployment of all network functions in Sparkle, as well as of information technology.
Great. Kevin?
Good morning. My name's Kevin Sheehan. I'm the CTO of the Americas for Ciena. And as the CTO of the Americas, I have a very talented team that works with customers on advanced solutions, typically involving software and software automation, advanced services, and then also on the networking side, kind of IP, MPLS solutions combined with optical networking.
Hey, Andrew.
And hello, everyone. My name is Andrew Dugan. I am with CenturyLink, and I have responsibility for the network strategy, architecture, and engineering for our global networks. And that includes everything from the fiber infrastructure layer, transport, MPLS, IP, voice, content delivery for our enterprise as well as our consumer services.
Well, we're going to start with talking about SDN and NFV and the cloudification. And this is something that we talked about, Daniele brought up initially when we were discussing the topics, and I'm going to let you start with that of, your experiences with, powering cloudification.
Yeah, thank you, Rosemary. So, long time already passed from when IATF was providing us with the definition of SDN about the separation of the control plane from the data plane, forwarding from control. From that moment, basically we have evolved. And today we can say that SDN is all about automation and programmability of the network. Many companies, and Sparkle primarily, we have proceeded with the implementation of these technologies. Today, several of our network functions are controlled by network service orchestrators. Automation and programmability are already a consolidated reality. All our IP MPLS network is already controlled by SDN controller. We are concluding tender for new transport network, optical transport network, and this will also be based on SDN controller. So we are creating an ecosystem of network functions that are working in a different way. Operations team are working in a different way on these network functions. After that came the virtualization. What we have done is the disaggregation of the network function from its underlying hardware. In Sparkle specifically, we started from the core because our main target when we decided to enter virtualization was operational efficiency, both in terms of processes but also in terms of cost reduction. Today we have the STP and diameter functions that are working on commercial off-the-shelf hardware, OpenStack, of course. We are proceeding in 2019 with the introduction of virtual IMS. So the result will be the complete cancellation of the hardware soft switch. All the voice business of Sparkle will run on virtual infrastructure. And we are on the verge of cost saving or about €1.5 million per year a regime. Still, we cannot speak about cloudification. In reality, what we have done, as I said, is the disaggregation of the network function from the underlying hardware. But in reality, we have created a new hardware dependency, because today, VNF are still designed as fat virtual machines, also going back to the discussion of our friend of Deutsche Telekom before. We always talk about virtual machines that are, of course, inefficient, that are grabbing with them all the overhead of the underlying operating system. Still, in order to make a virtual network function working efficiently, sometimes we have to pin it with the specific hardware resources, meaning that direct connection between the VNF and the underlying NIC, or direct visibility of SSD or hard disk controllers from the VNF. In order to move to the next step, that it's going to be, in my opinion, NFC, network function cloudification, there is the need of the industry of pushing towards cloud-native virtualized network function. What's the difference? The difference is simply avoid to design an application with all the complexity of the virtual machine around. Cloud functions, standard software as a service, are built today via software packages that are provided into containers. And these containers are instantiated into elastic computing infrastructures and run with continuous delivery and DevOps processes. So the next big step is going to be to design VNF in the cloud-native way. This will give us the possibility to further decompose the VNF. Specific microservices will be built and run in containers and can be located either at customer premises, edge, or whatever else.
Okay. Andrew, the types of, development that we just heard, how does that compare to the things that CenturyLink is doing?
In a lot of ways, very similar. I think there's two parts of the cloudification. One is the cloudification of a service provider network and infrastructure. And with that, we similarly have had some success with virtualization inside of our network around voice services, a lot of our content delivery services, and the network support functions. We've also had some success on virtualization for customer services. Running VNFs at the customer premise for providing services there, and then also in edge compute nodes where we have virtualized services running at the edge of the network. Those types of services tend to be managed routers, managed firewalls, and SD-WAN type services. We've had some good success in being able to deliver those. The other aspect of cloudification is the cloudification of our customers' networks. As our customers are creating more of a hybrid IT environment, they're taking their data centers, going to the public clouds, they're also going to public data centers, their applications are becoming more distributed. And they're getting used to the flexibility that those environments provide them to be able to turn up and turn down applications. It doesn't do them a whole lot of good to move their applications into the cloud without having the same level of flexibility and agility in developing network services. So we've been building our SDN Control Platform for several years to control our network infrastructure. And now what we're doing is we're taking that capability and turning it over to our customers to allow them to be able to build networks on demand that fit the distributed hybrid IT environment that they're creating. Some of the capabilities we've had success in the market with are things like dynamic capacity. So if a customer has a connection, they can scale up and scale down capacity on demand or based on triggers. They can also manage VLANs into the cloud environment for separation of traffic and management of traffic for different cloud instances that they have. And one of the newer ones that we just released over the last couple weeks is the ability to set up new connections between an enterprise location and a cloud environment, between two cloud environments if they want to connect those over a network with guaranteed performance, or from between their own data centers. So it's that supporting the cloudification of our customers' networks through dynamic services on our network, we think is pretty important as well.
Just to build on what Andrew was talking about from cloudification, you know, we've seen a lot of work with our customers and partners around automation of provisioning of services where, you know, the service provider often starts out automating the provisioning of connectivity, you know, maybe an Ethernet service or a wavelength service. And then we've seen more and more where there's a desire and projects to then layer cloud-based resources on top of the connectivity. So obviously it's great for the service provider. It allows them to provide value-added services. It's great for the enterprise customer too, because, you know, oftentimes some of the cloud providers make it very easy for an enterprise customer to do business with them, but not easy for the enterprise customer to go back and forth between different cloud service providers depending on the value on that particular day of the week for the service that they're buying. So, you know, this automation services can help with that a great deal for both the service provider and the enterprise customer. And, you know, upstairs, I know there's a couple of POCs. One I'm thinking of in particular that illustrates this is where the service provider has a customer portal, and the customer can go in and select in the portal both connectivity between points, and then they can input their, say, AWS billing information, and then layer through the portal, in that case, AWS services on top of the connection.
Survey that Stan mentioned that Vertical Systems Group and MEF worked on, that's just been completed, and you saw some of the results over the last few days. When one of the questions was about top priority about service orchestration within companies, and this was service provider survey worldwide, and the top priority, and this included carrier Ethernet and IP, was SD-WAN. 62% said that was their top priority for orchestration within their own company. So clearly it is top of mind. It is something that's growing. And why is that? I'm going to share with you one of the results from the survey, which is this, and that is because 82% in the same survey said that the top challenge as an SD-WAN provider is the lack of standardized interoperability between different types of devices. How scalable are these types of services, given where things are? Definition is one of the things that's being worked on with the MEF, highly needed. And then we'll talk about the outlook for managed services going forward. Andrew, you want to start on that? Sure.
Yeah, so we've had an SD-WAN offer in the market for 2 years, and you know, we started out with the Versa as the implementation, recently announced Viptela as a managed service, as well as expanding our offer to more than 30 countries around the world. So we have a little bit of experience, and if you would have asked me the question a year and a half ago around scalability, I would have been a little bit more anxious than I am today. Yeah. Some of the early challenges around building SD-WAN is that the technology itself and the capability that comes with the SD-WAN software, it's pretty flexible. And our customers hear about the technology, they come up with all of these creative ideas on how they want to leverage it to build their networks. And if you're not careful, you can end up with a custom implementation for every customer. The sales team goes and engages the customer and says, hey, I want to build this network. Of course, the technology is capable of it. Right. Sales team says yes and brings the order in, and then we're custom building networks for each customer. Right. That can create scalability issues from an operational standpoint. Those sorts of things we had to learn, and we had to figure out how to deal with. And the way we are dealing with it is we create standardized templates around the service configurations that we want the sales teams to position to customers. and bring orders in a more scalable that way. That helps solve some of those operational scalability problems. And over the last year and a half, we've been able to make significant scaling improvements with our ability to sell, provision, and manage services using those sorts of things.
Right. So that's been successful, just the upfront investment in trying to get those things done, right?
Yes, yeah.
Yeah, and that's, it's interesting because that is one of the top challenges for SD-WAN providers was resources, technical resources that are required to, up front, and as you say, and during the sales process, as well as the implementation phase and provisioning and, the design. Because nothing's plug and play. That's my favorite. There is no such thing as clear plug and play.
Yeah.
Daniele, you want to talk about your SD-WAN?
So, Sparkle doesn't have yet an SD-WAN proposition. We are still testing in our lab several vendor solutions, as well as experimenting on kind of self-developed with a system integrator, self-developed SD-WAN proposition in a kind of vendor-agnostic flavor.
Okay.
Let's start from the fact that SD-WAN is basically a set of technologies that allow a service provider to create an overlay virtual network that can span over different physical resources, being carrier Ethernet, being MPLS, being a transport network, being internet broadband access to the customer. And the two main targets are to provide enterprises an easy and smart way to interconnect branch offices and public clouds without the need of truck rolls. Having said that, going towards the scalability issue, let's say in most of the implementations of an SD-WAN technology, there is always a box that you need to deploy at customer premises. This box is already a critical point into the overall business case of the solution. I mean, both for the specific tenant, but also in terms of the economical business plan of the overall offering. Today, this box is still an extremely expensive device, especially if you want to size it in order to overcome eventual bottlenecks in terms of throughput, in terms of bandwidth requirements, or eventual, let's say, computing power. At the end of the day, you have to deploy an x86 server with all the drawbacks that are concerned. So this is one key element factor. Another thing that we have seen during our implementation, during our lab trials, is that there are still some solutions that from technical point of view, when you bring up a site, a customer site, the box there has to establish a virtual channel with basically all other boxes in the topology. This is a key factor for the scalability because basically it can limit you hardly in terms of number of nodes that you can deploy, and also in terms of performances, because it should be known in advance what are the borders in terms of max number of devices that are supported before performance started to go down. And another issue in terms of scalability, as it was reported in the chart, is the lack of standardized interfaces in order to guarantee that a service provider that is having a quite extensive network is obliged to use maybe in some region a specific technology that needs to interoperate with another region and another specific technology. Right. So from this perspective, the work that is being done in these days in MEF is of paramount importance because there is the standardization of this specifically with the multi-vendor approach.
Right. So Right.
Just to
So you're
conclude,
doing
I wanted
that.
just to say
Sure.
on the issue of the universal CPE that I spoke of before, we are presenting a proof of concept with Amartus that is exactly addressing this issue.
Right, right. And that's, you brought up the POCs a few times because the POCs are still open, and,
Yeah.
and if you haven't seen some of them, they're pretty impressive. So, so it's just in SD-WAN, Kevin, ask you the question on the, what's the outlook from the technology, solution supplier standpoint? How do you see that rolling out in the next years?
Yeah, so it's a great question. I think, SD-WAN is a technology where, to a certain extent, the end customers, the business customers, the enterprise customers, the demand was there before the solution was available. I think in Andrew's case, it's exceptional that they've had it out for 2 years and have multiple flavors of SD-WAN. I think that's not the norm. Most service providers are on the early part of the journey from my perspective. They maybe have a single vendor solution out there. It's not, it is providing layer 3 VPN and an alternative to MPLS, which has value associated with it, with the enterprise customers. That's why there were so many RFPs out there over the past couple of years from enterprise customers. But most of the deployments out there, from my perspective, don't tap into much more than providing that value-based layer 3 VPN. And the real promise, of course, is to be able to have some of that additional functionality that you touched on, Rosemary, that we haven't seen a lot of yet, and then ideally tying the performance of the VPN to performance of your network as a service provider. Because of course you don't want to be yet another over-the-top provider on your own network, right? You want to be able to differentiate from someone that might run the same service across your network and be able to generate some revenue off of it. And I think really to get to that next phase of SD-WAN, then it requires a little bit more of the standardization, like your survey indicated.
The next question we can move on to, and we talked about performance, and this is one which kind of gets into performance with mobile and edge computing and moving, closer to the customer. Take that one, Daniele.
Yeah, I'll start. It's our CEO has this saying. He says, wireless, it means exactly that, just a little less wire. And I think that's true with 5G. As you look at the way that people are deploying 5G networks and the density of the radios that they're planning for, it's pushing fiber deeper into the network. And with us being a fiber-based provider, there's some opportunity for us to do that. We plan to support that. The other thing that we think it will do is it will push compute needs closer to the edge. 5G is probably one of the earlier use cases of that. As the radios get very dense, the people putting up the radios don't want to have a radio controller at the base of every antenna. And so they'll backhaul that to a more centralized location. You can't go very far because of the protocols that exist between the antenna and the controller, but you can get some centralization. That will be a place where there will be an edge compute need, and those with fiber, space, and power to offer will be able to deliver those capabilities. Then there's the other use cases that could be driven by the capacity and users that are connected to these new networks. That we think is also going to drive a deeper cloud edge. Right now, I'll say it's a little unclear how deep that needs to be. We know that the radio controllers need to be pretty deep, but the applications that ride over top of that infrastructure, we expect that they will become, some of them at least, will become decentralized from the large locations where their cloud, traditional cloud providers are today. But do those need to exist, one per market? Do we need 4 per market? How many milliseconds of latency between the end user and where these compute nodes are. I think the industry is still figuring that out. We are preparing ourselves to support those capabilities as those applications develop.
Yeah. Daniele, you want to talk
Yeah.
about that and your perspective?
Yeah, actually, I fully agree with Andrew. Basically, with the 5G, we will have the rise of new connectivity services that are tailor-made for vertical industries. For example, automotive, for example, e-health. There will be 5G will be a strong enabler for IoT in general. This will determine the rise of specific network slices that are optimized for the specific set of requirements of the specific industry. Now, this will not be valid just for the radio access network, but will have to be somehow exported also to the backbone, as you said. Probably today's networks are not yet really able to support network slicing. In my opinion, we will have to virtualize somehow even optical transport networks with a multi-tenancy approach. So rather than having a single network orchestrator or a single network controller for the entire network that takes care about the automation and programmability of the entire network, most probably we will have hierarchies of domain controllers for the specific slice, because automation is something that will have to be taken care for the specific slice and for the specific set of requirements. This will probably accelerate the evolution of intent-based networking rather than the standard SDN as we know it today, on which basically there should be a kind of easy semantic interaction between a user and the controller. So we will be able to talk with Alexa and tell, create a network slice, please, with the specific characteristics. Yeah, a lot of impacts in the next few years.
Okay. Kevin, you want to?
With 5G, you have this cell densification, right? There's a lot more cell sites have to be present in every per square mile or whatever measure you want to use. And because of that, you can't build them the same way that you used to. You can't have all that active electronics right there at the bottom of the tower, whether it's a small cell, a light pole, or a macro cell. So now you're pulling those back even more than you did perhaps in LTE and centralizing them. But network timing is kind of the $5 billion question in this deployment. You know, so it's like, how do you achieve these rollouts in a standardized way, in an aggressive way, right? It's supposed to start to happen soon, around the time of Mobile World Congress next calendar year. How do you achieve that scale with the standardization to deliver that bandwidth with the network timing? There's a lot of work going into it. I think the other kind of unknown question is how much mobile edge computing will there be at the base of at least these larger centralized sites? I mean, we work with a partner. Some of their team is down the road here. They're kind of stealthy, called Vapor or Vapor.io. And Vapor is in the process of rolling out mobile edge compute sites at the base of large macro cell sites now in containers in conjunction with one of the big tower providers around the world. So they're making a big bet that mobile edge compute is going to be there, and that a lot of the content that we all access on our mobile devices today, and certainly in the 5G world, is the same content.
Right.
You know, the classic example is when HBO drops the next episode of Game of Thrones in the spring. That day when it comes out, some large percentage of the folks in this room will all be watching Game of Thrones, And so
Will they be watching on
could be
5G?
What's
Will they be watching on 5G?
Hey, that seamless connectivity, everybody wants it wherever they are.
All right, well.
It will be also interesting to understand how the evolution of the architectures of the mobile edge computing will affect the evolution of the, let's say, terminal devices. Because theoretically, having this amount of power at 1 millisecond of delay distance from the terminal, you could theoretically avoid putting a lot of resources within the phone or the terminal devices and rely on what you have at the base or macro station. So,
just kind of quickly, what we've been talking about is some of the, the hyperscale, the cloud providers, kind of calling the shots on a lot of connectivity issues. And Andrew, we talked about that with software, that they kind of dictate what they need because they, maybe just address that.
Yeah, so
as a challenge.
As we look at automating connectivity to support our customers' cloud needs, Kevin, you covered it, which is customers want to come to a portal and say, I want a connection from here to here, and put in their Amazon credentials and have that connectivity automatically connected into the cloud instance. That's a capability that we've built over the last year, but the challenge is there hasn't been standardization around those interfaces. The cloud providers were very early to the market around highly automated infrastructures. The standards like LSO did not exist at that time, so people built their own implementations. As we integrate cloud environments into our dynamic connectivity capabilities, we're having to adapt to each of the individual cloud providers' interfaces. It would be nice if there were standards around that, and I hope that with the work that MEF is doing, we get there. Because we would be able to implement it once and have connectivity to multiple other networks and other clouds. We'll get there.
We'll get there. Kevin, you think we'll get there?
Yeah, I think I agree with Andrew. I think it comes down to how fast we embrace the development environment of those hyperscale cloud providers, like I touched upon in my keynote yesterday, if anyone saw that. Whether it's jumping into green grass environment with AWS and all of us starting to develop in that, or whichever cloud provider we choose as a preference. But I think that is happening.
Yeah, I think customers looking for multi-cloud are in the needs of having a one-stop shop that can help them, first of all, to understand the complexity of multi-cloud, to undertake all benefits of the multi-cloud, where you are basically deciding in which cloud you deploy an application based on your business and financial needs. That is the main benefit of the multi-cloud. That is having then a number of, let's say, second-order benefits, such as the total removal of vendor lock-in, because you are not anymore locked into a platform like in the hybrid or in the proprietary cloud. And the one-stop shop, the service provider, should help these customers both to achieve the multi-cloud environment that they want to get in terms of computing resources, in terms of storage, but also in terms of connectivity. We have undertaken there a very good case. We have built a cloud automation platform that is having a single sign-on portal for our customer. We are good there.
Well, a lot to look forward to in the next year between clouds and 5G and SD-WAN and building automated, virtualized, interconnected networks, right? So we're out of time, but we appreciate your joining us today, and thank you very much to the panel. Give them a great hand.